CRAFS is the Corrugated Retention and Filtration System for Sedimentation Control. Its U.S. patent number is 9677243. Its corrugated system was developed for sediment control in critical spots with trouble conditions where silt fences fail. The three-dimensional CRAFS structure is engineered for vertical stability, to retain heavy loads of sediment runoff, and to resist the impact from debris carried in it. And that vertical stability supports the silt fences that are attached to both its sides. CRAFS provides a series of adjacent retention wedges that collect, retain, and filter sediments as the runoff seeps through the corrugated filter fabric structure. Each wedge puts lots more area of filter fabric next to the retained runoff than a silt fence would across the same flow path. That greater filter fabric area against the retained runoff provides a very rapid rate of filtered seepage with 95% trapping efficiency. Silt fences are the standard of practice for sediment control on earthwork construction sites and have been since the first approval by the EPA in 1975. They stop runoff from carrying the sediments off project boundaries. Initially, retained runoff slowly seeps through the silt fence fabric, but the fabric blocks flow as a filter cake of retained sediments covers its pores. Seepage through the silt fence is controlled by permeability of the filter cake, not the fabric. As runoff accumulates upstream, silt fence failures start to happen. The failures can be overflow and knockdown of the silt fence barrier, or seepage and scour beneath the silt fence toe-end. All these failures release sediment contamination onto adjacent properties, and that requires cleanup, regrading, and installation of another sediment retention device to stop the problem. The conventional solution to prevent this accumulation of retained runoff is to construct a stone outlet at low spots in the silt fence alignment. That's a check dam of coarse stone that allows the retained runoff to slowly flow through the stone's pore structure. It eliminates pressure from retained runoff that can cause silt fence failures. But stone outlets provide little to no retention and filtration of the runoff to prevent sediment contamination downstream. Until recently, sediment ponds to collect runoff within construction site boundaries have been considered the only effective method to prevent sediment contamination of adjacent properties or waterways. In theory, the pond will intercept and retain site runoff long enough for sediments to settle from suspension. Then the cleaned runoff can exit through a spillway onto adjacent property. Trouble with that conventional approach comes when heavy reoccurring rainfall events have already filled the pond. That's when runoff flows into and out of the pond so fast there's little or no time for particle settlement. So sediment contamination downstream is a given. CRAFS offers a proven low-cost alternative to stone outlets and sediment ponds. Its corrugated structure has stability to deal with stress from the sediment runoff it retains, and rapid filtered seepage to quickly release clean runoff through the system and away from the project site. And after project completion, the corrugated system can be removed by hand and hauled off in a pickup truck. There's no heavy equipment required. Upstream support posts of CRAFS splits the flow of runoff as it enters the corrugated system. That eliminates blunt impact of heavy runoff that can lead to instability of a conventional silt fence. The system's corrugated structure divides and distributes the runoff into one of the multiple of adjacent retention wedges that spans the incoming flow. It literally spreads the load of retained runoff. Each retention wedge prevents the lateral movement of retained runoff into adjacent wedges or into low spots at the outside edges of the system. This lowers the stress acting on the individual elements within the corrugated structure and puts more filter fabric surface area adjacent to the retained runoff. The upstream and downstream support posts, in combination with the filter fabric that spans between them, provides lateral load support throughout the system. The corrugated system acts as a truss network where all elements of the CRAFS structure work in tandem to resist the loads of sediment runoff retained. The same stability resists the impact of debris that often is carried in the runoff. That same lateral load support within the corrugated structure also provides stability to the silt fence system that's mechanically fastened to both sides of the CRAFS structure. CRAFS corrugated structure provides more filter fabric surface area adjacent to the runoff it retains than a silt fence spanning the same flow path. That significantly greater surface area provides a very rapid rate of filtered seepage through the CRAFS structure, and its retention wedges provide a 95% trapping efficiency to the fluid passing through the system. A conventional silt fence spanning the same width of flow will provide comparable trapping efficiency, but the retained runoff takes more than 4 times longer to seep through the linear barrier. On a conventional silt fence, a filter cake accumulates on the fabric surface with each rainfall runoff event. The seepage rate through the filter cake gets slower and slower as the filter cake builds. CRAFS corrugated fabric structure has more surface area of filter fabric adjacent to the retained runoff, so it takes longer for a filter cake to form and reduce the rate of seepage through the corrugated system. And that angular alignment of the CRAFS filter fabric relative to the direction of incoming flow causes a filter cake cleansing that rejuvenates the rapid filtered seepage through the system with each new rainfall event. CRAFS has a multiple of performance benefits that give its corrugated structure the stability and rapid filtered seepage necessary to get the sediment control job done. During its development, performance of the corrugated retention and filtration system was evaluated versus that of a linear system in both small-scale lab testing and full-scale field tests. Small-scale flume tests showed that both a linear silt fence and the corrugated system, or wedge system as it was referred to at the time, provided greater than 95% trapping efficiency. But the real difference in performance was the time required for total dewatering of the runoff retained. The retained wedge had allowed immediate and continuous filtered seepage through the wedge, while the linear retention system showed only beads of fluid dripping through the fabric. That very slow seepage was due to the filter cake of retained particles that were filtered from the incoming sediment flow. After the first hour of retention, the wedge had filtered nearly all the retained runoff fluid through its fabric, while the linear system continued a very slow trickle of water. The wedge had completely dewatered in 1¼ hours, while the linear system took more than 4 hours to dewater. Large-scale testing of CRAFS in the National Transportation Product Evaluation Program of sediment retention devices at the TRI Environmental Division lab in Anderson, South Carolina, showed similar rapid filtration performance for CRAFS. The corrugated woven monofilament filter fabric system had 95% trapping efficiency in their large-scale tests, just like the small-scale test showed. The retention and filtration performance of CRAFS is best shown on real projects where the corrugated system gets the job done in the field. The first few CRAFS installations solved silt fence washout problems. The failures were caused by accumulation of runoff at low spots. These critical areas needed a sediment control outlet that could retain and filter out the sediments as the cleaned water quickly seeped through. One of these jobs was installed at the Georgia Transportation Tower Project in Conyers, Georgia. A CRAFS unit was installed at the lowest elevation on the project, where runoff from the entire site accumulated. Originally, they had a parallel alignment of 2 adjacent Type C silt fences 3 feet apart surrounding the project boundaries. That's required by the Georgia Soil and Water Conservation Commission criteria. The parallel silt fences were structurally stable with support posts spacing on 4-foot centers. But despite the high porosity of the Type C silt fence fabric, seepage through the silt fence was so slow that retained runoff at the low spot overflowed during heavy rainfall events, carrying sediments into neighboring property. CRAFS was installed at that low spot adjacent to the existing silt fences. The corrugated filter system retained and rapidly filtered site runoff, so only clean water passed through to the adjacent double silt fence barrier. The cleaned runoff, with nothing to block flow through the silt fence, seeped quickly through both silt fences. That fast filter seepage through CRAFS lasted until the construction was complete. The temporary sediment control was removed. The job earned CRAFS the title of Control Outlet for Silt Fences. Several CRAFS control outlets were installed in Northern Virginia at the low spot of a silt fence alignment where multiple silt fence washouts had occurred. Before considering CRAFS, an earth berm had been built parallel to the silt fence as a first line of defense against silt fence washouts. But heavy rainfall events caused runoff to overtop the berms and wash out the silt fence in the low spots anyway. A CRAFS unit was installed in that low spot. Before installing the corrugated system, the earth berm in front of it was graded away to let runoff flow directly into it. CRAFS structural stability easily resisted stress from the runoff. That stability was passed on to the silt fences on both its sides, preventing their collapse too. And the rapid filter seepage through the CRAFS unit eliminated any accumulation of runoff water upstream or sediments downstream. Other CRAFS control outlets were installed in Northern Virginia, where a silt fence or smart fence fabric had been washed out by heavy runoff. Here again, structural stability and rapid filtered seepage from CRAFS solved the sediment control problem in a spot with trouble conditions. CRAFS control outlets were recommended by Draper, Aden Associates and approved by the Southampton County, Virginia Erosion and Sediment Control Administrator as an alternative to stone outlets at this solar project near Franklin, Virginia. Its approval was based on CRAFS' proven sediment control performance compared to traditional stone outlets. And ease of installation and removal made CRAFS the preferred alternative to the contractor. There were nearly 31 miles of silt fence on this project, with numerous CRAFS control outlets of varying lengths as designed per the Virginia Erosion and Sediment Control Handbook regarding temporary sediment traps. Some of the CRAFS units were up to 150 feet in length. Virginia Stormwater Pollution Prevention Plan requires sediment control inspection every 5 days, so the CRAFS control outlets were frequently monitored. According to Reagan Prince, the environmental specialist for Southampton County Environmental Services Division, who did the inspections, the CRAFS performed well during intense summer storms that produced 2 to 4 inches of rainfall over several days. No failures of CRAFS units were observed during inspections following significant rain events. The filtration system takes less materials, time, and equipment to install than a stone outlet, so its install cost is much lower, and maintenance cost is less too. And removal of the CRAFS after the temporary sediment control job is complete, it only takes a person with a shovel and a pickup truck to remove and haul the used CRAFS away. Compare that to the cost of a front-end loader, a dump truck required to remove a conventional stone outlet. The performance benefits of CRAFS can be used to replace a conventional J-hook, check dam, even a control inlet that are all often required in critical spots with trouble conditions. When silt fences surrounding a project's boundaries are on a steep slope and the retained runoff running down the slope next to the silt fence can cause severe erosion, silt fence J-hooks are often installed along the silt fence alignment to prevent that erosion. But heavy runoff loads can wash out J-hooks just like a silt fence. CRAFS J-hooks can solve that problem. At that Conyers, Georgia project, the overflow from a sediment pond atop the slope would more than double the runoff volume into the silt fence at the lower site boundary during heavy rains. A conventional J-hook washed out at that location during the first heavy rainfall event. The stability and rapid filter seepage of CRAFS J-hooks was all it took to prevent another failure. CRAFS is ideal for check dams. Its three-dimensional structure resists the lateral load from high flow concentrations, while its corrugated filter fabric provides rapid filtered seepage to prevent sediment contamination downstream. The site perimeter of the Hardest Senior Living project was surrounded by a silt fence. Heavy spring rains caused silt fence washout several times at a low spot in the south boundary. The project's consulting engineer specified CRAFS as a check dam and control outlet at that low spot to alleviate the problem. Control inlets and check dams are approved for sediment control in the Georgia Soil and Water Conservation Commission handbook, and a CRAFS control inlet check dam eliminated the sediment control problems at this site. Note that the close-up photo of the CRAFS retention wedges shows the sediments filtered from the retained runoff as its fluid had rapidly seeped through the system. Florida. The multiple adjacent retention wedges provide rapid filter seepage while the corrugated structure resists knockdown by the incoming flow. This close-up view shows how the structural stability of CRAFS resists stress from the debris carried in that retained runoff. Drop inlets are often filled by sediments and debris carried by runoff flowing into it. The retention and rapid filter seepage of CRAFS units can eliminate that contamination into the stormwater drainage system. Our CRAFS drop inlet protection system is preventing sediment contamination in the drop inlet of this collection basin in Jacksonville, Florida. CRAFS is not just a zigzagging silt fence. It's a multi-component system with a corrugated filter fabric structure mechanically bonded to an apron at its base that prevents flow below the corrugated filter and provides for a simple linear system toe-in to prevent scour beneath the structure. A specification including details highlighted here are necessary to assure performance from the corrugated retention and filtration system. A CRAFS spec must include the vertical corrugated filter fabric system, the horizontal apron, mechanical connection between the two fabrics, a brief on apron toe-in, description of upstream and downstream vertical support post sleeves, and instructions on system alignments. Also note that metal T-stakes are the recommended vertical support of the corrugated retention and filtration system for sediment control. T-stakes are to be 5-foot lengths of 125 pound per linear foot hot rolled billet steel. CRAFS will work with almost any stake used to give it vertical stature and in-place stability, but considering the critical spots with trouble conditions where CRAFS is used, metal T-stakes are recommended because they're easiest to drive deeply, vertically, and to reach firm resistance into the foundation soil below the corrugated system. CRAFS specifications should include the physical property requirements for the filter fabric and the apron of the system. CRAFS performance has been proven with a variety of woven and non-woven fabric components, various structural dimensions, and a variety of support posts. Those recommended as the standards for CRAFS are based on years of product development and field experience. Installation procedure for the corrugated retention and filtration system is a simple, straightforward process, but its structure does have critical steps required to assure proper alignment of its support posts, as well as tensioning of the filter fabric that spans between the upstream and downstream posts of the system. The installation procedure is summarized in a text document and in a step-by-step CRAFS installation video, both available within the product's website. CRAFS corrugated structure is a totally new approach for solving sediment control problems. It provides the structural stability and rapid filter seepage necessary to get the job done in critical spots with trouble conditions where silt fences fail. If you have questions regarding CRAFS product, technology, specs, or installation, you can find the answers on the CRAFS website or call 800-488-3636.